Hey, what's up? This is Václav. In the last video, I decided to reduce my dependency on the electrical grid. I analyzed my energy use. I made quite a few optimizations. If you missed that, check it out. With that, I also decided to get solar panels on the roof and some battery. Now, why I didn't do that a long time ago, you might ask? Well, my house is not situated ideally for that, I'm afraid. The front is situated to the southeast, and the roofs in front are smaller, as there are large windows and balconies. The opposite side of the roof is larger, but it's situated northwest. So I thought about solar panels in the past, but given the panels' peak power and their price compared to the energy price, I felt it just didn't make sense. But this is changing now. So while it's not ideal, I decided to give it a go. If I was a building or buying the house now, I'd think about that, but at the time, the usability for solar panels was not really the factor. The house is simply aligned to the street line. So here is my situation. The house is oriented 138 degrees, where south would be 180 degrees. The roof is angled 35 degrees and it's divided in two parts, with a flat part in the middle, which is unusable for a big part of the day as it's in the shade. Each half is 6 meters wide and 4 meters high. Not much. Today, the panels are typically 2.1 by 1.1 meters and have peak power about 450 watts. So I can fit 7 panels on each roof, 5 vertically and 2 horizontally. So both roofs will fit 14 panels. That will give me 6.3 kilowatt in peak. That's the maximum I can get with this stupid roof. And because of the roof orientation, I can expect they produce about 75% of what they would do if they were facing south. So I'll optimistically call it 5 kilowatt peak. If you look at the price of the photovoltaic setup, the most expensive part is the battery and the inverter and the installation. The panels are probably the cheapest bit. So I was trying to maximize their power. There are panels with higher peak power, but they're larger, so I will fit less of them on my small roof. So that won't work. I'm also trying to think about some creative ways to put panels on the other roof, but because of the orientation, they won't make an electricity for most of the year, but very limited in the summer. But at least something. Perhaps lifting them and make them more horizontal would help a bit. I don't know. Still trying to figure this one out. Or putting few of them on the flat roof, even if they'll be in the shade in the afternoon. And there's the first thing I learned about photovoltaics. Initially, I thought that every panel counts. So when I have an empty place on the roof, I'll just smack a panel somewhere and it'll do something. Turns out it's a bit more complicated than that. First, you can't easily combine panels in different orientations, as the panels in the shade would not only work, but they would cause energy loss of the other panels producing energy. There are some solutions with bypass diodes, but I'm not sure how that would work in this case, south versus north. So the way this is done is you put the panels in different strings. Putting the panels in the same orientation in the same string. That's great, but there's one more thing. The inverter has some minimal voltage. Until then, it just won't work. Also, the inverter has some internal consumptions, and you want to make sure it does not consume more energy than the panels produce. And so, considering that, turns out the northwest-facing panels might not actually do anything. And just throwing more panels into that won't work either. First, there is legal limit, currently 10 kilowatt peak, which I can't go over, which is 22 panels. And it would probably require a more powerful inverter, even though they won't actually produce that much power, but I think they'll just add up the peak power of all the panels. So different contractors had different ideas. So let's see if we can figure something out. Now, during the exercise, Home Assistant is actually quite handy. There's a great integration for Forecast Solar, where you can configure the location, peak power, and orientation of your panels, and based on the weather forecast, it will calculate the current and forecasted energy production. Let me show you. With my configuration, it figured that in the summer, it will be able to produce maximum 47 kilowatt hours per day in a sunny day, and somewhere around 30 on particularly cloudy day. Obviously, on a rainy day, it will produce nothing. I found this table with average daily production for 5 kilowatt peak in the Czech Republic. It shows the average around 20 kilowatt hours per day during the summer. So this is what I will use in my planning. This is also the reason I want to reduce my electricity consumption to hopefully get under that number. I also try to model the panels in the back. It calculated maximum between 5 to 18 kilowatt hours per day, but I'm not really sure I can count on that given the minimal voltage and that the panels would only start to catch some sun in the afternoon. Now, that is in the summer. In where I live, in Central Europe, the panels will produce energy from sometimes in March till September, maybe a bit in October. But from October till February, that'll be of no use, I'm afraid, especially with my stupid roof orientation. Then the battery. The Tesla battery is not simply available in here, so I don't know much about that. But we have different ones. The one I got was Pylontech H2. What I like about them is they're modular, so I can start with 3 modules initially, and I can add 1 more if it would make sense. So that the batteries are quite expensive. I consume about 20 kilowatt hours per day, and I consume most of the energy during the day in the summer. That means, assuming I can use the solar energy during the day and charge the battery, 10 kilowatt hours battery will carry me throughout the night. The common setup is 10 kilowatt peak solar panels and 10 kilowatt hours battery. I will have about half of the PV power, and I will still get the 10 kilowatt hours battery, and I will see how it goes. I can stack extra module in it that could get me through the day without sun, but then with the reduced panels power, I'm not sure it will produce enough energy to charge the bigger battery. I guess I will see. Also, I have an electric vehicle that has much larger battery than the one in the house, which also means that hoping that I can charge the batteries during the day and then charge the car at night won't work. So it makes no sense to consider that in planning for the battery capacity. We would rather try planning to charge the car during the day. On the other hand, there are some experiments with using the car battery when you don't need to use the car, but then the battery is the most expensive part of the car. So that'll be interesting. We will see. So now I know what I want. So let's ask for proposals, compare them, and pick the one that I thought was working best for me. Fingers crossed. But I'll do that in the next video. Until then, bye.